Don't just use technology, understand it. Love technology? Subscribe to Explainer 99.
Welcome to today's Explainer. We are jumping right into the invisible, everyday magic that literally powers our daily commutes. I mean, if you take public transit, you interact with this technology all the time, probably without giving it a second thought. But right beneath the surface of that quick tap at the gate is this truly fascinating world of physics, engineering, and massive data networks. Seriously, think about it for a second. You walk up to a gate, you tap a little plastic disc or card, and boom, the doors slide open. Later, you tap out, and it magically knows exactly how far you went and exactly how much to charge you. Have you ever actually wondered how a completely dead piece of plastic knows exactly where you traveled? How is it communicating without a power source? Well, here is a roadmap for today's Explainer to answer exactly that. 1. The magic inside tokens. 2. The split-second handshake. 3. Closed loops versus open loops. 4. Behind the turnstile glitches. And 5. The future of metro fares. Okay, let's dive into this with Section 1, the magic inside tokens. The absolute secret sauce here is RFID, which stands for radio frequency identification. This is basically a technology used for wireless communication between two components via electromagnetic induction. Now, to make this really simple to picture, imagine a small radio in your pocket. But this radio doesn't have a battery. It's completely dead. It only turns on and broadcasts its message when you walk close to a massive broadcasting tower that essentially blasts it with enough energy to wake it up. That is exactly what's happening when you hold your token near the reader. Hiding right inside that plastic shell is a very specific anatomy, which generally follows the MIFAR standard developed by NXP Semiconductors. Inside, you have three crucial things. First up, a tiny microchip. This is the brain of the whole operation. It stores your unique ID, your current balance, and the code of the station you just entered. Second, an antenna coil. This is a tiny, tiny wire wrapped in a circle that receives and sends signals. And third, passive power. It literally requires no battery whatsoever. The entire system just sits dormant until you need it, which is exactly why these cards and tokens can live for years in your wallet without ever needing a charge. Moving right along to Section 2, the split-second handshake. This entire interaction happens in less than a single second. It's crazy fast. Here's how it actually goes down. Step 1. The reader installed at the metro gate is constantly emitting radio frequency waves, just waiting for a tag. Step 2. As your token gets close, those radio waves power the tag through electromagnetic induction. The antenna coil in your token literally harvests energy straight from the air. Step 3. The newly powered tag transmits its secure, encrypted data back to the reader, sharing your station code, validation period, and authentication keys. And finally, Step 4. The gate verifies the encryption so it can't be cloned, calculates the fare, and opens. All of that data is exchanged, verified, and logged in the blink of an eye. So the really crucial point here is the speed at which this happens, and that's made possible by a highly specific frequency, 13.56 megahertz. This is the high-frequency communication rate of modern smart technology used in these transit networks. To put that into perspective, this frequency allows data transfer 100 times faster than older 125 kilohertz proximity technology. That incredible speed is exactly why you don't have to break your stride when you're walking through a busy subway turnstile during rush hour. All right, let's shift gears to Section 3, closed loops versus open loops. When engineers are designing a transit network, they generally choose between two architectures. First, you have closed-loop systems. This is an offline system where your actual money balance is stored physically right on the microchip inside your card. The readers at the gate do not need an internet connection to let you through. That makes them incredibly fast, and crucially, it prevents catastrophic bottlenecks if a network suddenly goes down. By contrast, we have open-loop systems. These are online, operating directly over bank networks like Visa or MasterCard. They don't require you to maintain a separate transit balance, which is nice, but the massive disadvantage here is that they require a constant split-second network connection to your bank just to approve the transaction. Now, if you live in a city with a closed-loop system, you've probably experienced this exact frustration. You recharge your Metro card on your phone, you get to the station, and your card still says empty. Like, why? Well, it's because online recharges do not reflect immediately. Since your card is acting as an offline wallet, the physical chip just hasn't received the memo yet. You actually have to tap your card at a kiosk, an add-value machine, which is the only thing connected to the internet. That kiosk downloads the update from the server and writes the new balance physically onto your card's microchip. This semi-offline architecture, like the one used in India's NCMC rupee cards, is just a brilliant compromise to keep turnstiles moving instantly without relying on spotty underground Wi-Fi. Let's look at what happens when things go wrong in Section 4. Behind the turnstile glitches. If you ever see a gate completely frozen, or maybe a screen that says something like PI is restarting, you are looking at a standard operating system reboot. The PI is basically a core part of the turnstile's internal computer. Just like your laptop at home, it sometimes needs to restart, and that process can take up to 5 minutes. But what about a total power failure? Well, transit systems have built-in fail-safes for that. If the turnstile loses power entirely, the electromagnetic locks disengage automatically. This safety mechanism lets the turnstile swing freely, allowing for safe and free exit in an emergency. Sometimes, though, the failure isn't the gate at all, it's your card. The antenna coil inside can literally break if you bend the plastic too hard in your wallet. For years, this was an absolute nightmare for commuters. But there is really good news happening globally on this front. For example, in Delhi, commuter policy was recently updated so that cards reported unreadable due to technical reasons are now replaced instantly and completely free of cost right at the station. That is a huge upgrade from the old system where you literally had to wait 5 days for a replacement. And we really can't talk about glitches without talking about the human element. Behind every automated gate are thousands of workers keeping the tech running. Just look at the massive recruitment drives for the Hyderabad Metro's Phase 2 expansion. They are hiring thousands of people across the board. You've got station controllers managing the flow of passengers, rolling stock maintainers fixing the physical and electrical systems, and ticket counter staff running the automatic fare collection systems. The reason this matters is simple. This seemingly magical automated tech relies entirely on a massive, well-paid human workforce operating behind the scenes. Finally, that brings us to Section 5, the future of metro fares. Looking at the history of New York's transit payments tells an incredible story of legacy systems giving way to modern tech. Back in 1953, the famous physical tokens were introduced. 40 years later, in 1993, the Metro card arrived, relying on magnetic stripes. But magnetic stripes require mechanical swiping, which wears down both the card and the reader over time. So they started experimenting with early RFID contactless trials back in 2006 with MasterCard and Citi. But it wasn't until May of 2019 that they finally launched OMNY, One Metro New York, a massive system-wide upgrade to modern contactless technology that was actually based on London's Oyster card system. And this brilliantly illustrates just how massive an undertaking it is to upgrade a legacy transit system to an open-loop model. It's an absolutely monumental feat of engineering and funding. Get this, when the OMNY rollout launched in May 2019, the budget was just under $645 million. By November 2020, as they outfitted buses in all 5 boroughs, it ballooned to $732 million. And by June 2021, it hit $772 million, installing thousands of high-speed 13.56 megahertz readers across subways, railways, and buses, and then integrating them directly with global banking networks, scales costs at a truly staggering rate. But why does this all matter to you, the rider? Well, it's about what you get in return. Open-loop systems like OMNY enable some really amazing features, like automated fare capping. With OMNY, the system actively tracks your credit card or smartphone taps. Once you hit 12 taps in a 7-day period, every single ride after that is completely free. The system essentially realizes, hey, you've spent enough to buy a weekly pass, and just stops charging you. The cap resets every 7 days, and there's even a reduced fare cap of $17.50 for eligible riders. Just a quick heads up though, if you're tapping for your whole family, group taps don't count toward your individual cap. You have to use the exact same card or device for every trip to get the benefit. Which brings us to a really fascinating crossroads. We've moved from physical metal tokens to magnetic stripes to passive RFID plastic cards that require no battery, and now we're jumping directly to tapping our smartphones and Apple Watches. But as incredible as the open-loop smartphone revolution is, it leaves us with one highly practical vulnerability to think about. As smartphones entirely replace physical transit tokens, what happens when your phone battery dies on the subway and you need to tap out? I'll leave you to ponder the conveniences and the vulnerabilities of our increasingly digital future. Thanks so much for joining me on this explainer, and keep asking questions about the hidden tech all around you.
Love technology? Subscribe to Explainer 99.